This is a W14 by 1000. It's the largest rolled structural steel shape in the world. But when most in the construction industry hear W14, they picture a shape that's about 14 inches deep. But this one, 25.2 inches. So the obvious question is, why on earth do we call this a W14? And to answer that, we need to start with how wide flange shapes are named. A W-shaped designation has two numbers. The first is the nominal depth. The second is the nominal weight per foot. But the key word here is nominal, which literally means in name only. Just like a 2x4 isn't actually 2x4, a W14 is not usually 14 inches deep. It's really just an identifier, more like a model name than an exact measurement. And even the weight has some flexibility. The nominal weight is the intended value, but ASTM allows a tolerance between 2.5% and 3%. So how does a W14 end up over 25 inches deep? And there's a few reasons: production, history, and the utility of what's hidden in a name. Let's start with production. Steel mills don't roll every shape as a completely unique product. They roll shapes in families. And just like our families, every member is different. But they all share some common DNA, so to speak. Let's take a look at the W14 column shapes, for example. Across the family, you'll see different depths, flange thicknesses, flange widths. But underneath all that variation, if you look closely, there's a shared genetic code. If you take the total depth and subtract the thickness of both flanges, you get the same number every single time. That's not a coincidence. And that constraint drives everything else. It dictates how the shape can grow and what it can become. And that number comes from production at the mill. In a universal mill, a hot beam blank passes through a series of rollers. The universal stand forms the web and flanges, and the edging stand shapes the outer edges of the flanges. Within a shape family, mills can change the section they're producing without changing the rollers or mill configuration. Adjust the web thickness, adjust the horizontal rolls. Change the flange thickness, adjust the vertical rolls. Change the flange width, adjust the edging stand. But one thing doesn't change: the width of the horizontal roll. This locks in the distance between the flanges and defines the entire family. The mill can scale this way down or way up. Let's say they start with a W14 by 145. As the flanges and web get thicker, the shape evolves. It gets heavier and deeper and deeper until you end up here with a shape that's 25.2 inches deep. This is what makes production efficient. There are nearly 300 wide flange shapes in the AISC Steel Construction Manual. If each one required a completely new set of rollers, production would be incredibly complex, slow, and expensive. Instead, mills can produce an entire family line from the same setup, only modifying the space between the rollers. So why don't we just rename these shapes as they evolve? Why not just call this a W25 by 1000? Surely the mill can just account for the fact that it rolls in the same family as the W14s, right? That comes down partially to history. This naming system has been around for nearly a century. It first appears in the early AISC manuals in the 1930s. And once something like that becomes embedded in the industry, it's really difficult to change. There's design software, CAD libraries, specifications, manuals, decades of engineering habit. Everything is built around the same system. So instead of renaming shapes, the family name stuck as the members evolved. The shapes weren't as big back then either, so the difference between nominal and actual wasn't what it is today. The family tree expanded, and the newest generation looked a lot different. The other reason the family name sticks is because it gives us useful information. Picture a column line in a building. As you move up the structure, the columns usually step down in size. If we stay within the same family, the family dimension stays the same, as the flange and web thickness steps back with each size reduction. This method allows the columns to stack cleanly. With a shim and a splice plate, the connection is fast and easy. If you're only dealing with thickness changes, there's no reinventing the connection for every unique situation. The family name also gives us insight into when a shape is going to be produced. Because mills roll shapes by family, multiple sizes are often produced during the same rolling campaign, so the designation can help indicate availability and lead times. It's easy to assume that larger, less common shapes are produced less frequently, but in reality, production is driven by the family schedule, not individual sizes. If shapes within a family were renamed or broken apart, that connection to how steel is actually produced and how it becomes available would be lost. So while it may seem odd to name a shape that's 25.2 inches deep a W14, there is method to this madness. And as that family tree continues to grow, more people might grow more confused. So make sure to subscribe to stay up to date on the latest and greatest in structural steel.